So, chapter 5, we're doing a lot of function manipulation. Okay, we're starting out today with composite functions. A composite function is a function inside of a function. Okay, it's composed of. That's what this little dot here means. That means f composed of g. That's what a composite function is. It's not a degree sign. It's composed of. So it's f composed of g of x. Means that I take g of x, stick it inside of f. Whatever my function f is, I take g and I put it inside that function. That's what a composite function is. I'm taking a function and sticking it inside of another function. You will do a pretty fair amount of work with composite functions next year. Part of it being breaking bigger functions down into smaller pieces. That's what you're going to try to do. Is you're going to look for the inside function. You're going to look for the part. Okay. So today we're just going to kind of play around with them a little bit. So I have to start with, I'm given two functions. F of x is the square root of x. G of x is defined as x squared minus 5. Using that, I need to find f composed of g of negative 3. What does that mean? That means I need to find f of g of negative 3. That's what that means. F composed of g of negative 3. That means I take negative 3, plug it into g, figure out what that number is, take that number and plug it into f. That's what that means. Okay, it's not a difficult concept. So I take negative 3, plug it into g of negative 3. That's negative 3 squared minus 5. Negative 3 squared is 9. 9 minus 5 is 4. Okay. So if I'm finding g of negative 3, well, g of negative 3 is 4, so I want to find f of that. So that means I'm looking for f of 4. Because g of negative 3 is 4, so I plug in 4 into f. F of 4 is the square root of 4, which is 2. So what is f of g of negative 3? It's 2. That's a composite function, taking a function, sticking it inside another. Okay. Same thing, g composed of f of negative 2. G of f of negative 2. So I'm not finding g first and sticking it in f, I'm finding f and sticking it into g. The order in which you get them matters. First one is f composed of g, this is g composed of f. So what am I looking for here? I'm looking for g of f of negative 2. Question? G of f of negative 2. So what do I need to find first? F of negative 2. So f is the square root of x. So f of negative 2 is the square root of negative 2. What is the square root of negative 2? Trick question. Yeah. We are dealing with functions, which means we are dealing in the realm of real numbers. So what is the square root of negative 2? Does not exist. Because we're dealing with the realm of real numbers, I is not in the realm of real numbers. The square roots of negatives can't happen in the realm of real numbers. So we're back into the realm of real numbers now. We're not going to have I as part of our work. We're not part of the complex problems. Okay, which means that this one is D N E, does not exist. Now, if our inside function does not exist, can we take G of something that doesn't exist? No. So that means that this does not exist. D N E. If you can't do the first one, you can't do the second one. Yes?
Did you also say no solution specifically?
This would be, well, I'm not solving it, so it's no solution. It's better to actually say it does not exist. There's a subtle difference between no solution and does not exist. Does not exist is actually a better description of what's going on here. Okay. If I were to graph the function f, if I were to graph the function f, the square root of x, that would go from 0, everything to the right. -2 is not in the domain of the function square root. If it's not in the domain, then it doesn't exist. And I think that there is a subtle difference between the two. If on a test you said no solution, I probably would not mark you wrong, but there is a subtle and important difference between the two. Okay? Like I said, on the test, I might not. But this is something that if you had this next year in Calc, D and E is what you need to have. Does not exist is what you need to have. Okay? So it's one of those things. There are things that I let Algebra 1 students slide on that I don't let Algebra 2 students slide on. There are things that I would let you guys slide on that I will not let a calculus class slide on. Difference between D and E and no solution, I might let slide in here. I would not let slide necessarily in calculus. Because when you take the AP test, they will be picky about that. And it will not equate the two. Okay. So the last one. G composed of G of -1. This is not G of -1. This is G of -1. What you have to do is you have to find what G of -1 is, take that number and stick it into G back into it. You can have a function composed of itself. That's okay. You can take a function and stick it inside itself. That works out just fine. So in this one, I need to find G of -1, which is -1 squared minus 5, which is -4. So that means I take this -4, plug it in here. So I'm finding G of -4, which is -4 squared minus 5, which is 11. If I take -4 squared, it gives me 16. 16 minus 5 is 1d1, 11. Okay. Well, 11 is 11, but 22 is a 20 and a 2. We don't do 10d1.
Wait, are we talking about Stranger Things?
Okay. Questions? Any questions? Okay. So I will do the first one here because I want you to understand G composed of f of x. G composed of f of x. Okay. So this one here, G composed of f of x means I take f of x and stick it inside G. That's what that means. G composed of f of x. I'm not evaluating it in a particular number. I'm just making a new function out of my other two. This is kind of important. What is f? F is x plus 1. So I'm actually taking G of x plus 1 because f of x is x plus 1. Which means wherever I have x and G, I put x plus 1 instead. G is 2x minus x squared. So I have G of f of x is 2 times x plus 1 minus x plus 1 squared. And then you simplify. Distribute the 2. 2x plus 2 minus, take x plus 1 and square it and change the sign of everything. Minus x squared minus 2x minus 1. It is not x squared plus 1 squared. It's like plus 1 times x plus 1. Somebody did that on the test. Okay. 2x minus 2x, they cancel each other. So I have negative x squared. And then I have a 2 minus 1. So I get negative x squared plus 1. I created a new function from two other functions. Okay. G composed of F means I take F, stick it inside G. Okay. If it's F of X, that means I take F of X, stick it inside G, and I do evaluate that. Simplify it. I created a new function. Okay. F composed of G. Question? Yes. No, you're done, because there's no equal sign, right? So all you're doing is simplifying it, making it look pretty. That's all we're doing at this point, making it look pretty. Because this is not pretty. This is pretty. Okay. In mathematical terms. This is fine. We love this too. Does not matter how it looks to us. We love them all. We love functions, equations all equally. Just some are aesthetically a little more pleasing than others.
Feels like that's what my parents say about me.
Yeah, probably do. Okay, so here's what I want you to do. There are two more up here. F of G of F of -5 and F of G of 1. Find those two, please. Okay, so let's go ahead and do these. G of F of -5 means I'm finding G of F of -5. Find F of -5 first. F of -5 is -5 plus 1, which is -4. Piece of cake. Take -4, plug it into G. G of -4 is 2 times -4 minus -4 squared, which is -8 minus 16, which is -24. So that's my answer is -24. Yes?
So you also just put -5 into F of G of X?
Yeah, you can do that. You can do that. You can. Good question. Yes, you can do that. You can find G of F and then plug it into there. Plug -5 in there. You should, yeah, you do get the same thing.
Yeah.
You can plug it into there. That's a good question. I'm glad you brought that up because I completely blanked on that. But because we do know what this is, we can just take -5 and plug it into there. -5, -5 squared plus 1, and what do you get? You get -24, the same thing. So it is nice if you've worked out the problem before. I'm glad you saw that because I didn't see that. If you've worked out the problem before for something else, you can just plug it into the composition you've already created with X's. Is it worth it to do? On this one, F composed of G, I would not find F of G of X first. I would do this just numerically. But if I already had F of G, I'd just plug 1 into that. Does that make sense? So good. I'm glad you saw that. Thank you for bringing that up. Because I missed it completely even though I was doing the notes. Okay. And so let's do the last one. F of G of 1. G of 1 is 2 times 1 minus 1 squared, which is 1. So that's F of 1, which is 1 plus 1, which is, I hope you all got the right answer on that and got 2. I hope by now you can do 1 plus 1.
Yeah, well, we have graphing.
Yes, but still won't help.
Yeah.
Okay. Domain of composite functions. So particularly if I'm looking at the domain of F of G, but remember you can make composite functions of any two functions you have. You can actually do composite functions of several of them. F composed of G composed of H. Take H, put it inside G. Take that, whatever you get there, put that inside F. So you can have several composite functions. Okay. If you're looking at the domain, any X that is not on in G must be excluded. So if you're doing F composed of G, if you're dealing with F composed of G of X, nothing that's in G is allowed. So the inside function, if it can't be part of G, it can't be part of everything. So if we look at the original problem, the one we did a while ago where we said it does not exist, it didn't exist in the inside function, therefore it doesn't exist in the composite function. Even though I could have taken square root of x and plugged it in and squared it and gotten everything all cleaned up, it would have worked there. Because it didn't work in the original one, it doesn't work in the composite. Okay. After that, any x which g of x is not in the domain of f must be excluded. There, I'll put that down so you can read a little bit better. And you'll kind of see a little bit better as I do a couple of examples. Okay, so what does this mean for what we are doing here? I want to find the domain of f composed of g. So the first thing, because it's f composed of g, I need to look at g first. Are there any domain restrictions for g of x in that first set? 0. X cannot be 0. There's my first domain restriction. That comes strictly from g of x. Now here's where things get a little trickier. Okay, so I look at f of x. What am I not allowed to have in f of x? And I'm not looking for a specific number here, but what am I not allowed to have when I have a fraction? I'm not allowed to have 0 in my denominator. So that means whatever I add 3 to cannot be equal to 0. Now, because it's f composed of g, I'm actually looking at 1 over g of x plus 3. Because it's a composite function. I'm taking x replacing with g of x, which means that g of x plus 3 can't be equal to 0. That's what that means. That's my restriction. Whatever g is, plus 3 can't be 0. So that means negative 2 over x plus 3 can't be 0. Let me solve it. It's actually not as hard as it looks. Okay. So I'm going to add 2 over x to both sides. And I get 3 equals 2 over x. Let's get that down to give me a little more room. And here's the cool thing. I've got a couple of ways I can solve this. Easiest way to do, multiply both sides by x. Okay. There's a lot of ways to deal with fractions, though. There's a lot of ways to deal with fractions. Whenever you have a proportion, remember, you can cross-multiply a proportion at any time and solve it. The other thing you can do, and most people don't realize this, is that I can just take that whole proportion and flip it over. As long as I flip both sides, it's still the same. So if I flip both sides, I end up with x over 2 is equal to 1 over 3. Because you can do that. If you have a proportion, you can just flip them both. There's lots of rules of proportions. Cross-multiplying works. Flipping them both over works. Exchanging the extremes or exchanging the means also works. Okay? Multiply both sides by 2. X cannot be, because we're talking about not equal to 2/3. Okay. Now, to thoroughly confuse you, I know what some of you are thinking. Too late. Let's write this in set notation, because that's the way it will be in your book. That's the way it will be on the answer key for your worksheet.
Could you not multiply 3 by 1 over 2?
Yeah, you can do that. No matter how you solve it, you're going to get the same thing. I'm just trying to show you a trick. And if you have something more complicated, sometimes doing the flipping is the best first step you can do. If you have like 1 over the square root of x plus 3 squared in your denominator, you have some big nasty square root, 1 over that, just flip it over and flip over the other side. It makes it much easier to solve. Okay, often it will do that. So, my domain is the set of numbers x such that x cannot be equal to 0 or 2/3. It's a lousy looking bracket, I know. My domain is the set of numbers x such that x cannot be 0 or 2/3. Anything else works. This is set notation. Okay. You have interval notation, you have set notation, you have lots of different ways of saying the same thing. Set notation is what's in the note. Set notation is what you're going to see probably in the book. Set notation is what you will probably see on your answer key for the worksheet you're going to use tomorrow. So let's take a look at the next one, number 4, because that's the hard one. Yes?
Would you be okay if we answered it in the way right?
Yeah, but I want you to be able to do this as well. The more ways you can do it, the better off you're going to be. Partially because the more ways you can do it, that shows me that you understand the different ways of being told to you. Okay. If you gave it to me, if you gave me x can't equal 0 and x can't equal 2/3, yeah, I'd be all right with that. Okay. So, same thing on the next one. My g can't be what? 1. So this one, x cannot equal 1. Because 1 will give me my denominator. And now panic time. It's not that hard. Okay. So I have 1 over x plus 2 is f. I'm not allowed to have whatever's in the denominator equal to 0, which means I cannot have g of x plus 2 equal to 0. That cannot be true. I'm not allowed to have 0 in my denominators. Whatever g is plus 2 can't be 0. So that means I have to figure out what g plus 2 is. What values of x give me that? So 4 over x minus 1 plus 2 cannot be 0. That's what I'm trying to find. Subtract 2 from both sides. 4 over x minus 1 equals -2. Cross multiply. 4 equals -2 times x minus 1. You can solve this any way you want. Distribute, divide. I actually, at this point, prefer to divide both sides by -2. So I get -2 equals x minus 1. Add 1 to both sides. X, and we're actually dealing with not equal to here. So I got -1 and +1. So my domain is the set of all numbers x such that x cannot equal plus or minus 1. So if I take 1 and plug it into g, I get 0 in the denominator of g, not allowed. If I take -1 and plug it in the denominator of g, -1 minus 1 is -2. 4 over -2 is -2. If I take that number and plug it in here, what do I get? I get 0 in that denominator. That's why it cannot be 1 or -1. 1 makes that 0. If I take -1, plug it into here, it makes that 0. Makes the composite 0. Okay, take a minute, do number 5. Okay, so we're doing with f composed of g, so first we need to look at g. What are my domain restrictions on g of x? There are none. My domain for g of x is all real numbers. Yay, I have no domain restrictions there. I do, however, have domain restrictions for f. What am I not allowed to take the square root of? A negative number. So that means whatever I'm taking the square root of must be greater than or equal to 0. Because if I'm taking f composed of g, that means g needs to be greater than or equal to 0. So that means 2x plus 3 needs to be greater than or equal to 0. Subtract 3. 2x is greater than or equal to negative 3. X is greater than or equal to negative 3 halves. Okay.
Why is it greater than?
Can I take the square root of a negative number? Can I take the square root of 0? Remember, when you're talking domain, 90% of the time it's 0. The rest of it, it's either positive or negative. It's what you're not allowed to have. It's the easiest thing to look for.
It's all real.
In this one, there's all real numbers because I can take anything and add 2, multiply it times 2 and add 3. There's nothing I can't do that to. Okay. So my domain for f composed of G is the set of numbers x such that x is greater than or equal to negative 3 halves in set notation. All right. Show that f composed of g of x is equal to g composed of f of x, which is x. So what you do is you take f composed of g of x. You take g of x, stick it inside f of x. You simplify it. You find g composed of f. You take f, stick it inside g, simplify it. Show that those two are equal to each other, which is x. It's actually not as bad as it looks. So f is 3x minus 4. This is g. This is f. So the first thing I'm going to do is I'm going to take g, stick it inside f. So I have 3 times whatever g is minus 4. And g is 1/3 x plus 4. And I simplify that and see what I get. Okay. What's 3 times 1/3?
1.
1. So I have x plus 4 minus 4. What's x plus 4 minus 4? X. That's f composed of g. Now I need to do the same thing, g composed of f. So I have to take 1/3 of whatever f of x is and add 4 to that. And simplify that down. So inside the parentheses, 3x minus 4 plus 4 is what?
3x.
3x. So I have 1/3 times 3x, which is x. Okay. Foreshadowing. 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 It'll make sense to you tomorrow why we did this today, or next time we meet. Oh, this is a big one. This is the key to doing 2 very important but somewhat difficult things to do in calculus next year. Okay? Chain rule and U substitution. Those will be big deals next year in calculus. This, if you get this today, it will make it so much easier next year. What we're trying to do is we're trying to find 2 functions, f and g, such that f composed of g is equal to h. We're trying to break down h into, we're trying to decompose, as it were, h into 2 functions. The inside function and the outside function. Because I'm using f composed of g, that means I have f of g of x. I have an inside function g and an outside function f. What I'm trying to do is break down the big function into 2 smaller ones. Trust me on this one. This is a big deal for next year. Okay? Just this basic concept will make things a lot easier when you get to that point. It's not as hard as it looks. Probably the most difficult one is actually the first one. I have 2 functions that make up h of x. I want to figure out what they are. What is my inside function? What is my outside function? On these ones here, and there's a trick to it, my inside function is x plus 1. If I think of this as g, okay, as my inside function, I label g of x as x plus 1, make that my inside function. What is f going to be then? 1 over that. If I put them together, what do I get? I get 1 over what g of x is, which is 1 over x plus 1. Generally speaking, when you have fractions, this is how it's going to work. Generally speaking.
Where's the 1 go?
No. This would go into there. When I put them back together, that's what's going to happen. So my inside function is what my denominator is. My outside function is 1 over something. In this case, it's 1 over g of x, which is x plus 1. Right. The next two are actually easier to see. What's my inside function on the next one here? What's the inside function going to be? 2x plus 3. This is my inside function. That's my g. So g of x is 2x plus 3. F of x. What am I doing to 2x plus 3? Raising it to the 4th power. So f of x is x to the 4th power.
Is there like a special name for like putting something to the 4th? Like something to the 3rd?
It's no, there isn't.
Anything greater.
Actually, quadruple is 4 times. That's the 4th power.
Let's make up something.
Next one. Once again, this is a piece of cake. What's my inside function? X squared plus 1. That's my g. So g of x is x squared plus 1. What's my outside function? The cosine of x. Yeah, when you have parentheses, almost always what's inside the parentheses is your inside function. What you're doing to whatever's your inside parentheses is your outside function. Those are a lot easier. When you have fractions, it's kind of the same way. Whatever's in the denominator is your inside. The fraction without that denominator is your outside function. If you have square roots, what's inside the square root's your g, your square root's the f, generally speaking. So it's not that hard to break it down. This is an important skill. Okay. And last but not least, we're going to create a composite function to describe this situation. Spread of oil from a leaking tanker is in the shape of a circle. Oh, isn't that convenient? It is the radius r in feet of the spread after t hours is r of t equals 200 root t. Find the area as a function of time. So, area. What is the formula for the area of a circle? Pi r squared. Okay. But I don't want it in terms of r. I want it in terms of t, because it wants a of t is what it wants. So if I want to find a of t, that means I need to find it, take r of t, plug it in for r. So if I want a of t, then I need to take r, replace it with r of t, and plug in that function there. So it's pi times 200 root t squared, because that's what the radius is in terms of time. 200 square root of t squared.
Is it air? Is the a subtracting?
No. I'm just arrowing it.
Oh.
Arrow, sorry. Take r, replace it with the function r of t. Now I get a of t. Simplify. What's 200 squared? Oh, come on. What's 2 squared? 4. How many zeros do I have here? 2. So how many am I going to have when I square it? 4. 40,000 pi times t. Holy crap. Really? You can't square 200 in your head? Square the number, double the zeros. Tell you square a number followed by a bunch of zeros. Square the number, double the zeros. Okay.
Roseberry with the green.
That's all, folks.
Here, guys, do clone